Okay. Whenever you're ready, Bradley.
All right. So yeah, as Sean mentioned, my name is Bradley, and I build stuff and I do some consulting. And my primary customer right now is actually the same company that that Sean works for, and we're using Golang in a lot of stuff, and I've used it on quite a few projects now, and just thought it might be interesting to give a talk on it. So let's just jump right into it, and let me share my screen here. And it looks like, Sean, that you've disabled attendee screen sharing. So I think you have to enable that in order to let me share my screen.
All right, try it now.
All right, cool. Okay, so this is interesting. I have to actually, because, let's see, it apparently didn't have access to a screen record before. It's telling me that it can't screen record until it quits, unless it's lying. Can you all see my screen?
Let's see.
I can see your screen, but I only see one bar, like a designer bar.
Yeah.
One bar.
I see your mouse. A play button.
Okay, so
there we go.
There we go.
Can you see the whole thing? Okay, cool. So let's do this. Let me wait, all the popovers that Zoom has are kind of annoying. All right, so let's just get into it then. So this talk is an intro to Go, and another title for it, because I always like to do kind of like fun optional titles, is called You Can Go. One of the things that I want to kind of cover before I really get into the meat of the talk is that this isn't so much a how-to or a let's build a thing together. This is really just some of the things that I like about Go, and some of the paradigms within Go, and then I'm going to show a demonstration at the end, kind of tying that all together. So you're not going to walk away from this necessarily having an outline of like how to create a web server in Go or anything like that. But what you're going to have is just a set of paradigms and things that I find interesting and useful about Go and the Go platform. So who wants to be a gopher? One cool thing about Go, as any technology stack that kind of gains a lot of traction, is that you have a lot of people that get involved, a lot of different opinions, ideas, thoughts, and a lot of different just output that people produce, right? So you have the Go gopher, and one of the cool things about Go is that their caricature here has been kind of embraced, and so you see lots of different variants of this guy. And so I would just say that, like, no matter what kind of developer you see yourself as or whatever, there's some Go for you. All right, so let's explore together. Here's what we're going to talk about. We're going to talk about why is Go? Why does Go even exist? What was the purpose of the people that started it? A little quick tidbit about how you can get started with Go. We're going to look at some of their types, their conventions. We're going to look at tests and docs. And then at the end, I'll have some resources for you. So first off, why is Go? One of the things that you'll pull from the FAQ about Go, if you look at their the reasoning behind why they created it, was, and the emphasis here is mine, basically they wanted to help the working programmer by enabling tooling and automating mundane tasks, such as code formatting and stuff like that. I love their emphasis on tooling. And an interesting thing is that Go, when people say Go, it actually refers to two things. It refers to the language. The language is called Go. It also refers to the Go tool. So what they did was they, with the language of Go, they built a Go tool that is used to compile, run, stuff like that, Go programs. So keep that in mind, because there's going to be some different commands that are going to be like Go XYZ, and that's the Go tool. And yet the program that you write or compile would be a Go program with the Go language. So getting started is actually really easy. At least on Mac, I've not really done this on Windows, so I can't say for sure. However, the instructions look fairly simple. On Mac at least, or I would assume Linux would work pretty close to this same as well with like maybe apt-get, but with Mac, you can just do brew install go. That's the easiest way to do this. And then that's how you install the Go tool. Then what you can do is you just tell the Go tool that you want to init. So it's kind of like how npm init, and it will kind of scaffold out a package JSON and stuff. I'll ask you some questions. Go mod init actually doesn't ask you any questions. You just give it a module name. So the module name typically follows a pattern like github.com/user/some project would be a standard way to do that. So next, what you would do is you would have that module kind of initted, and Go is going to create what's called a mod file, which is basically the name of your module, and then it's going to start tracking any dependencies that you pull in. And so just as the package lock JSON would track your dependencies, this is going to do the same thing, except for Go. So what's a Go module? A Go module is basically a thing, or kind of like a bundled set of functionality that you expose from some area. Typically it's in a repo, like this one is https github.com onsci/ginkgo. So onsci is the user, /ginkgo is the project, or the repo. The module is github.com /onsci/ginkgo, and within a module in Go, you will have multiple packages, or often multiple packages. You could have just no packages and just have everything in the module. You could have tons of packages. So this one has, for the Ginkgo, which is a test runner, it has types, reporters, config. It has the Ginkgo, like the main Ginkgo package. It also has internal. Convention-wise, Go has some opinions. It doesn't have a lot of them, so it's kind of, I believe, a good balance between opinionated, do things this way and this way only type of paradigm, as well as for other things, there's not really a strong opinion. So you have a good balance there, because sometimes it can be daunting when you're working with something that's new to be like, oh, well, how should I structure a thing, or how should I name a thing, or how should I do a thing? With Go, it has kind of a set of what I feel are pragmatic paradigms, and naming wise, one of them is to name a package internal if you don't want it to be importable by other things. So this is really cool, because not only is it a notion of private and public, which you also have, but it's a notion of private, or I'm sorry, public to my module, private against all other modules. So if I pull in the Ginkgo module, I can import any package that the Ginkgo module has, except whatever's in the internal folder. Typically, packages are represented by folders. It's kind of typically how you would do that. So what you can have is you can have certain things that are in internal that's like, maybe this is dangerous to use type stuff, kind of like think about like the React's dangerously set in inner HTML, right? So if this were a JavaScript thing, I don't really know that you would have a way to say, I have these things and my project can use them, but nobody can import them. Because if you import something from like NPM, you can access basically anything in it, as if it's public. With internal, if I'm over in my types package, I can import all my internal stuff and do maybe some, prone to error type functionality, or some really kind of like crazy functionality I don't really want getting out, or stuff that just nobody really needs to ever mess with. And then I can only export what I want to from my types package. Does that make sense? Does anybody have any questions about the naming convention for internal packages and kind of what that's used for? All right. So let's look at some types. Types are fun. with Go, you have kind of all the basics. So they have a very strong standard library. You have your primitives like string and float, map. You also have functions. Functions are first-class citizens. And we hear that a lot. Like in JavaScript, functions are first-class citizens. In some languages, they're not. So what does that really mean to have functions as first-class citizens? The definition that I found that kind of makes the most sense to me is that any language that allows functions to be typed, which basically means that I can create a type that says it's a function that has certain parameters as certain return, and then I can then expect in input parameters or in return arguments that it's a function of that it's a value of that type. So you can allow them to be typed, you can pass them as parameters, you can return them as return arguments. That would be a first-class citizen, as a function being treated like a first-class citizen. Next, we'll have like objects and shapes. So you have a thing called struct, which is the object in Go. You also have interface. Interface is really cool because it's a little different than the languages that I've worked with otherwise that have interfaces, except for TypeScript. But as far as like kind of back-end server type languages, you can declare an interface in any package. Like for instance, stringer is an interface that literally just means you have a string function on the type on the object, and it returns a string. It has no arguments, it returns a string. So if I have a function that takes a stringer, it could be your stringer, my stringer, somebody else's stringer. It doesn't matter as long as the type implements that interface, and you don't have to declare that you implement the interface. Go just says, hey, this signature matches, you can pass for this. So that's pretty nice. Reflection is a first-class citizen. One of the things that, so I kind of grew up on C#, and you can do reflection in C#, but it's kind of frowned upon, and you're going to take performance hit, stuff like that. This is .NET. I don't know anything about C# or about .NET Core. So this is like .NET 2 through 5, I believe, were kind of like my main experiences with .NET. But with Go, reflection is actually kind of a first-class citizen. Basically, it's very easy or cheap to do type assertions. A whole lot of any Go code that you're going to look at is going to be doing type assertions because it is just really cheap to do. So the cool thing is that it allows you to do very, very flexible type stuff, but it still gives you the safety of strong typing. So I can take in, there's a type called just empty interface, which is just basically anything would fit this type. And then I could do some type assertions and say, is this an integer or a string? And if it's an N64, I would treat it one way. If it's a string, I would treat it another way. And if it's anything else, maybe I'd throw an error or something like that. There's not really throwing errors in Go. There's really, it's kind of a different paradigm, but that's not really for this talk. So you can check, is this value in N64, or does this value implement a certain interface? So that's very useful. All right, conventions. We've already talked a little bit about conventions on package naming. This is a convention on your variables and stuff like that. So public versus private. Rather than having to declare this thing is public, this thing is private, and it's always to the package. So within a package, which is, again, just think of it a folder, really. Within a folder, I could have 11 files. The number of files doesn't matter. They're all going to be in the same package typically. And anything that is public would be public to other packages in that would import that, that package. So you could have an add to that is public, and you would know it's public because it's title cased. You could have another add to that is private, and that one's private because it's lower cased. So it doesn't have to be lower camel case, but basically just the first letter is lowercase. I kind of like that because it gives you just a quick indication without having to actually read keywords. This is public, this is private, and you don't have to type out the keywords either. So that's pretty nice. With variable declaration, there's a couple different ways to declare variables. You can do the colon equal syntax, which is when you declare plus a sign. And typically it's going to look kind of like that. You have something, you're declaring and setting it to some value. Now I have to declare or I have to explicitly put in the assign here that that's a float 64, because as with a lot of typed systems, you have different types of floats, right? You have float 32, float 64, all that kind of stuff. So 23.99 could be a float 32, could be a float 64. So I'm going to just tell it it's a float 64. Otherwise, you can declare it on one line. Say I have var something, it's float 64 type, and then somewhere down the road, I can set that variable to a value. And I don't have to explicitly tell the compiler this is a float 64 because I've already told it the type of this variable is float 64. So because 23.99 is coercible to float 64, it's just going to automatically do that. If you gave it like a string there, it would obviously tell you, hey, this isn't a float. You can't do that. Object instantiation. This is going to be a sticky one. Some of you may hate this, and that's totally okay. I'm going to give you my opinion because I'm the one talking. But you do not have constructors in Go. Now, this was very hard for me to get used to at first. I was like, how do you do anything without constructors? Very interesting thing about Go is that Go is not a traditionally object-oriented language. It is, in my opinion, it is a very good middle ground between object and functional paradigms. So you have objects that can kind of extend other objects, and you have, or types that can kind of extend other types. You can add functions to those types and add functionality. So like I could have a function on the person type called like full name, and it would print first name plus last name. But what you cannot do is you cannot have a constructor on a type. So what you see very, very often in Go is you see factories. And after doing this for quite a while, I have come to the line of thinking that actually makes me write cleaner code, especially on a back end where you may have multiple types. Like let's say you've got a transaction, a credit card transaction. Well, we work in my main customer, the one that Sean also works for, is in the payment industry. A lot of that stuff is pretty complex, and a lot of it has multiple different things. So like if I have a payment transaction from one processor versus a payment transaction from another processor, there's gonna be core things that are in common, but there's gonna be a lot of things that are very different. So what you would have maybe typically in like in the OOP styles, you would have a constructor and you would pass in some options of what it is. And it would you'd have this massive constructor function that goes through and says, oh, if the object looks like this, do these things. If it looks like this, do these other things. With Go, what you're going to find a lot is your package would just export the type that's available and then factory functions. New, let's say I have two processors, processor A and processor B. New processor A transaction, new processor B transaction. And then you know exactly, even though they're both going to return a transaction, the contents within them, stuff like that, might be processed a little bit differently based on the differing types. So you can do the keyword new as well, but what that's going to do is that's just going to initialize a person, or in this case, it's person, but it could be whatever, with the default values. So if you have a person that has like a string first name field, it's just going to be empty. You can also do an initializer where you do ampersand is if you want to get a pointer. You don't have to use the ampersand. You could just get a value instead of the pointer. And so you could then use the curly braces and you could tell it, here are the fields that I want to go ahead and set. Otherwise, you can use kind of the factory mechanism. All right, any questions on public-private variables, declarations, and object instantiations?
I was going to ask about the ampersand sign, but you answered that question. It's a pointer. So you're basically initializing an object, giving it some values, and saying, give me a pointer to that thing.
Correct.
Right.
So Go is very C-like. I would say it's kind of in between C# and C++. So basically, there wasn't and probably still isn't, I don't know, I don't do C++, but one of the main complaints at that time that they built Go was that there just wasn't any tooling getting better around the C++ ecosystem. And so they were like, there's a lot of things that like Java, but the Java runtime, the Java, KVM and stuff like that, those are heavy, right? Those aren't lightweight. Even the C# runtime is not super lightweight. One of the things that Go kind of specializes in, or kind of like what I've heard set as the sweet spot, which I build web servers with it. I've built socket-based backends, CLIs, like you can build whatever you want. But one of the things that it's really catching fire for is your infrastructure type stuff, because it gives you very close to the metal, like C++, but it gives you just enough niceties that you don't want to hang your head in shame after working with it, you know? C++
Right.
is pretty painful. And so like Kubernetes, if you've heard of Kubernetes, it's built with Go. There's a whole lot of, there's a message bus called nats.io that's pretty popular. It's built on Go. There's a whole lot of that kind of like infrastructure and ops type stuff that's built on Go, but then there's also going to be more and more and more web servers and a lot of microservice stuff built with Go. It's just, I don't know, it's just really good. I've really come to enjoy it.
I've heard people describe it as C++ if C++ was invented now instead of, 50 years ago.
Yeah, essentially that's the case. And it saves you a lot of the heartache. You don't have to like dereference your pointers. So you don't have to deallocate memory. So it does have a garbage collector. It does have a lot of that, all those same things kind of built into it. It's just
Nice.
It's just really lightweight, and it gets you as close to the middle as you can probably be without using C++, at least until something else comes along. And I'm not one that's like big on benchmarks, because the reality is like you can code something terribly in any language, I feel like. And so a lot of times benchmarks are a little bit subjective, because there's just been so many times I've seen them where somebody comes along and adds a comment to like, oh, if you'd have written this other way, it would have done it totally different. So you can't be an expert in like all the things. So I'm not necessarily one that cares, oh, it's this many IOPS per millisecond versus Node or versus whatever. I still use Node. I still like other things. This is just something that I also really like and thought would make for a fun talk. All right, so now that we've gotten, I'm sorry, were there any other questions on the boring content thus far? All right, so now that we've gotten through the boring stuff, let's go to the demo. So this is the fun stuff here. So let me, my mouse went away. That's obnoxious. There we go. So let me stop sharing here and let me open up my demo real quick. All right, let me share that one. All right, so this is, again, this is not going to be a how-to or a anything like that. All that this is showing just some of the things that I've come to like, and just to give a demonstration of those things and why I find them so powerful. So this is a very basic Go module with a package. The package is a DAL, or data access layer. One of the things that we're going to be looking into is a tool called Go.Doc. This is, again, the Go tool, and there is a command on it called doc. So I have here in my project a type called person, okay? Notice that above my type called person, I have some comments, and some of them are indented, so, stuff like that. So, okay, so I'm gonna do Go.Doc person. Now, I don't know of any other languages that let you do this. I've not experienced many of the languages that are out there, so there may be tons, but this is super cool. So I can tell Go to document the person type here. It tells me to import, I would have to import it as dot, because basically it's saying you're already in the package that this is in. It tells me the type, it shows me the comments that were added to the type, and it tells me all of the public functions on that type. Okay, well, that's pretty cool. What about the standard lib stuff? So what if I want to use something in the standard lib? So I can do Go.Doc, let's say like strings, okay? So Go.Doc strings. A lot of stuff in the standard lib strings package. You would just import strings. Well, what if I'm looking for something and I'm like, oh, this compare, that looks like it might be what I need. A, B, string and it returns an int. Okay, cool. Go doc strings.compare. All right, and then it gives me the full set of documentation that was assigned. So one of the things that was their focus was, again, tooling, and they were like, hey, if we're gonna have it as a convention that we write comments on our types that are exported, because internal types, non-exported, again, public versus private, their verbiage calls it exported versus non-exported, but it's really kind of the same thing. For all the exported things, the Go, if you use like Go FMT, which is again another Go tool, again focused on tooling, it really wants you to add comments to things that are public. And if you're going to say that our convention is to have descriptions and examples and whatnot in our comments, that obviously it's not dictating what you write as the comment, but more or less that you have comments, and that typically you want like a full sentence, typically with like a period. I should have had a period there. You can indent things to have like code snippets and stuff like that. If you're gonna have that kind of convention, then you ought to like use that convention to the maximum ability. So GoDoc tool was invented, and it's like, hey, we can do this thing, and it gets even better. So we can tell Go to document a type in a package, a function on that type. Let's do something a little bit better. Let's do GoDoc. Now this is what I was typing earlier was Go space doc. What I'm typing now is GoDoc. This is a different tool, but it kind of uses that same uses the same underpinnings as the GoDoc tool. Okay, I'm gonna do GoDoc, and then I'm gonna go. I think I can only share one screen at a time. I think. Can you all see the?
You could pull the window over into this other one, maybe.
Yeah, let's try that. Okay, can you all see the browser, or no, or is it just the VS Code?
Are you just sharing the browser or
Just
VS Code? Yeah, just VS Code.
Okay, well, let me do this. Let me nix the VS Code share, and let me share the other one. Can I just do my full screen? I'll just do this. I'll just do the full full desktop. There we go. All right. So, okay. So I'm running this on localhost 6060. That's the default. And all I did, let me arrange my windows here. All I did was run GoDoc. All right. So what does this give me? Like, what's the purpose of this? Well, I can go into package, and I can see all of the standard library packages. So let's say that I'm doing something like with crypto, and I want to see, oh, how do I do like an MD5 with crypto? Well, it shows you, and all of these comments are generated, or all this documentation is generated from the code comments themselves, and it also all links together. So it shows me that there are constants here. Here are the constants: your block size, your size, and then it can show examples. These examples are done, again, based on a convention thing. But how cool is that to say, oh, here's an example of using an MD5 hash and what I can expect the output to be. Also, it tells you the files. So I can go right to a file and see what exactly the source looks like. And this is all running locally, and I didn't have to do anything except tell GoDoc to run. All right, well, that's the standard lib. What about my own code? Okay, and one of the things, I build APIs. I'm working on a pretty extensive one right now for a POS software, those are huge. And one of the things that's a struggle is to have good documentation. And we're using Swagger and stuff like that. But then I also refer people to the GoDoc, because the GoDoc gives me awesome documentation for free, as long as I have decently structured code and decent comments. So let's check out. So we see that you have github.com, Bradley Gore, docs demo. Well, let's see what's in docs demo. It tells me what the package is for. It has these headers. So let's look at these headers. Let's get how did that happen. So we'll go to my docs demo document. So here's kind of the top level comment. Anytime it sees just a line separated by empty lines, with just a fragment, like not a complete sentence, it assumes that's a header. Anytime it sees like these hyphens, it assumes that's like a list type thing. Anytime it sees a link, it's gonna automatically linkify it for you. So I can open a new tab that is, well, let me go, I think I stopped sharing. Sorry. There we go. So I can go to that link that it opened. Also, examples. All of these examples are based on unit tests. So how many of us here unit test our code? Or I guess I'd ask the opposite. How many of us are against unit testing our code? Okay, good. I'm going to take that to mean nobody.
Better not
So
be any hands raised.
What's that?
Better not be any hands raised.
Yeah, if there are, let's have a conversation. I'd like to understand. I've never seen a point counterpoint go well for the side of no testing. I'll just put it that way. So I have a type called occupation, and it has a function on it called moniker. It returns a string. The example here is that for different occupations, because it's like an enum, right? So I have an occupation for doctor of philosophy, medical doctor, coder, and then a different one. And it has different monikers, right? Okay, so how did I get there? How did that happen? Well, let's look at this example. And again, it's a convention. So there is some buy-in, but I believe in using this for, I don't know, 3 or 4 years now, I believe the conventions aren't so, it's not so dogmatic that it's like that you find yourself fighting it all the time. It's just enough convention to give you some structure, and the rest is kind of up to you, you know, but I think it's pretty nice. So I have this example occupation test file. The naming is example, directly followed by whatever type. Then if you're going to do like a function on that type, you would do underscore some function. So all I'm doing here is I'm showing the usage of the thing, and then I just put comments that show the output. And here's all of the output that I expect to be done to the standard out. And then so what it does, the Go.Doc engine behind the scenes, is it actually runs this code, and it examines the standard out, and it shows. I'm sorry, the Go.Doc would examine this and then examine this and show you like what your expectations are, right? If you run go test, so this is a unit test. So let me do a new thing here, and I will do go test v. And what we can see here is that the example occupation moniker runs and passes. Like it is not just for documentation. This is also a unit test that vets the functionality of my code, right?
That's awesome.
So yeah, like how great is that? So it vets the functionality. It gives me documentation for free. Like I didn't have to do anything. I don't think anything here is like unbearable or crazy. Okay, so let's go to something a little bit different then. So I have it in the data access layer, and this is just a dumb little package that exports one function called getOne. It exports a type called record, and I have different types of tests. Very cool thing about Go is that it lets you do multiple returns. And at first I thought, oh, that's kind of ugly. But in the paradigm of Go, what they kind of came to realize, which if you've worked in C#, you know that if you have a thing that can throw an exception, you've typically got to try to catch on 11 different exceptions, because the thing that can throw an exception can throw 11 different exceptions. The paradigm for Go is that anything that can return an error, rather than throwing a thing and letting the runtime, hopefully that it's caught somewhere, you just build your functions such that they return whatever they should return plus an error. And you could have functions that return 15 arguments. It's a thing that like you can do it, but should you? So obviously I'm not advocating for abusing this, but it is a good paradigm to say, okay, I've got a function. It can either return a thing if all is good, or it returns an error if stuff is not good. It's not a panic. A panic in Go is like basically, oh crap, something major happened and we need to shut everything down kind of thing. There's a function called panic, and it basically kills everything. You can trap on them, but it's kind of not something you should do a lot, because you should only use panics in like dire straight type scenario, right? Like I expected to have a database and I have no database, or I have a database and there's no records all of a sudden. Like that's a BFD, right? So what we can do is, this is obviously dumb logic, but if the ID is 5, we return a record. Otherwise we'll return, and then nil for the error. Otherwise we're going to return nil for the record and then an error because it's not the ID we were looking for. So the example test for that, we're going to get one, and then again, the naming convention here, underscore, but there's not like a function off of the get one because it is a function. So this is really just more like a scenario. So this is the get one function that we're showing an example of in the success scenario. And this is a get one function with the error scenario. And again, it's the same exact things before. We just show the code in use and we show what the output would be. And that gives us our error and our success scenarios here, right? All right, one final thing that I want to show you, or maybe two. So what about bugs, right? So we all hate bugs. Bugs are unavoidable. How cool would it be if there was a living, breathing documentation that tracked that for us? Oh, wait, look, there's bugs documented right here. So on my moniker or on my greeting type, the logic right now is that the person says, hello, I am, and then with their full name, and I am a, whatever their occupation is. The bug here, and typical convention is that you would do like bug and then parentheses, whoever either found the bug or should fix the bug. Sometimes you'll see like XXX, like anybody that can fix this bug. And you'd have the description of the bug. A person shouldn't really greet with their occupation in this case. Of course, it's arbitrary, it doesn't really matter, but if you saw what happened there, I literally just clicked on the bug and it took me right to the line of code that has the bug marked. So I don't know. I find stuff like this like just super exciting, super useful. I'm all about the utility of a thing. And this stuff like this, I just find it useful and awesome. So there's one package that's kind of like the main package to look at for code examples like this, and it's the sort package. So I want to take a look at that real fast, and I'll show you just how good this kind of stuff can be. So the sort package has a lot of sorting utilities, kind of as you would expect, and it has all these examples, tons of examples, right? So if you're wanting to see how do I sort some numbers in Go, okay, well, here we go. Here's some quick numbers. Okay, well, what if I want to do, let's see, something a little bit more complicated. Of course, I expanded all of them, so now I have to scroll through all of them. Here we go. There's an interface. Remember I told you about interfaces and how that like, you don't have to declare that your type implements an interface. There's an interface in the sort package. It's the only interface, so they just named it interface with a capital I. And all that it has is 3 functions. Len is so you can get the number of elements. Less is so you can determine whether an element with 1 index is less than in the sort order the other element. And then swap is just to trade places. Like if one is not in the proper order compared to the other one, swap them, right? All right, so the example, so we can look here at like the type. Again, we can navigate full code, and then I want to look at the example. Let's see here. Oh, here we go. So like this. So we have a planet type, and there's these functions to like sort by a certain thing. And we can see like, here's their whole usage of how to use that interface, right? So of how to sort by keys, how to sort by like the sort wrapper thing that they've got. The documentation is just awesome. And so all this code actually runs. So, one thing that we can do go.doc play, and what it'll do, there's a thing called the Go playground, which most languages have a playground, right? But with the Go playground, if you run the go.doc in play mode, then any packages that are, obviously this would only work with like the standard lib packages, because if you have like a private local package, the Go playground can't really run that because it is it's a hosted server. But if I have a code example here and I'm like, oh, how do I sort some numbers? Or how do I do this thing in descending order is what this example is. You can run it and you can see, oh, this is exactly what the Go runtime would return. So there's like a lot of functionality with the Go docs, and there's even more. There's just all kind of crazy stuff, but there again, just enough convention to kind of give you some framework to work with, and extremely useful. So that's really it for me. I think that's, let's see. So we've got some resources at the end here. Some of the things, and I'm going to share all this stuff. They'll post it in the meetup, but basically golang.org, that's where you can read and learn. There's also like tutorials that they have on there. Then you have play.golang.org, which is just the playground. I find it extremely useful. You can just like start typing away and just execute some code and see what happens. There is the Go FAQ, which I've already referenced, but it's also really good because I'm big on answering the question of like, why is this thing available? Like, why did somebody make this thing? You know, there's that whole that adage of like, oh, there's 15 different loggers, and so we need to create one unified logger to standardize them all. And so now what do we have? 16 different loggers, right? So the FAQ is pretty informative as far as like what problems they were trying to solve, why they created the language. There's also the documentation on Go testable examples, and there's the Ginkgo test runner. It's kind of, I just threw it in there because it's pretty well written code. It's a DSL for running tests, and it's just a really good test runner. So if you do, as you can probably tell, I'm a big advocate for testing your code. So if you do start writing Go code, I would advocate that you test it. Just the practice of testing, in my opinion, makes people a better coder anyways. So please look at those, and that's it for me. Thank you. Any questions or any feedback that folks want to give?
That's friggin' slick. But have you worked with Go routines or channels very much?
Yes. Yeah, that's a, I really wanted to kind of just show, that is a thing I love about Go. The mechanisms for doing concurrency in Go are astounding. I mean, if you did task.start and stuff like that back in like .NET 3.5, something like that, then you're gonna love the simplicity of Go routines and channels. They're amazing. It's just, I felt like that was a little bit higher level for this talk, but yeah, I use them all the time. I mean,
that's always been one of my favorite things about Go.
Yeah.
Cool.
Yeah, the concurrency paradigm's fantastic. Channels are interesting. It's easy, as with anything that that allows you a lot of power. It's very easy to kind of abuse it and create new bugs. But once you start wrapping your head around that, so there's just a lot of cool stuff. Look up a talk. So if you're interested in this kind of thing, look up a talk that I believe he was French. It was at one of the Go community meetings, and this guy was showing how he got a single server to support like 2 million. Now they weren't doing anything, so it's not like high processing, but he got it to support 2 million concurrent WebSocket connections. And what he was doing was he was really making like maximum use of shared Go routines, channels, and stuff like that. And so I took some of those paradigms because the API that I'm building is socket based. And so I would estimate that even under load on a single server, I mean, I don't think there's any reason we couldn't have thousands of simultaneous users under heavy load. I mean, I'm not going to say million, but I'm going to say way big thousands. That's what I'm hoping for anyways. So we'll see.
Do you find yourself doing more socket-based APIs rather than like RESTful with Go?
I've done both. There is a very good HTTP API that's kind of similar to Express if you've done Node, which I think you have. So
Yeah, I have.
Express has like the way they do the routing and then the middleware. There's this one called Gin. So if you do like a search for like Golang Gin, Gin, like the drink, it is an HTTP server that's super fast, has really nice middleware functionalities. So another type of API that I do in Go is, and it's fairly new to me, so I only started doing it this year, is gRPC. And that's actually really fun. You can do middleware in gRPC, but that is fast as hell. And so one of the most common use cases that I'm aware of for is server-to-server communication. So like if I have like a kind of macro service architecture, so if I have my auth service that controls who people are, who can do what where, all that kind of stuff, you can do a gRPC connection, which is essentially a persistent connection between one server to another server, and you can make those requests really, really fast. Like I've got a request that came in to do a thing. I have this user. Can this user do this thing in this place? Yes or no? And then now you execute the thing. That's working out really, really nicely. And the middleware paradigm there, just like with HTTP servers, is actually really strong. And so we've done things like, I'm a huge fan of middleware, and I like lean controllers with only the logic that specific controller needs and everything else in middleware. So it's like battle tested, reusable, stuff like that. So we have like all of our, if a downstream handler returns an error, we have a normalizer that basically tries to see, okay, is this an error that should go to the requester, or is this some kind of internal error that we should just log it and then mask it, right? Because there's certain information you don't want to ever travel over any of the wires. And we've got middleware that does that. It's actually been really, really good. I'm really, really looking forward to doing more with that. But yeah, so all three of those types of APIs. And then then CLI tools. I've built CLI tools with Go. I've also built them with Node, like Yargs is one of my favorite argument processors, or whatever you call it. But yeah, there's similar things for Go. One is called Cobra Command, if I remember right. So that's just, the name is just cool, right? But yeah, so kind of all the things really I've done with Go, all the same things that I've done with Node, and I've just come to really enjoy it.
Nice.
So we probably got enough for like one more question if anybody has it.
Okay.
All right. If not, I'm gonna thank the sponsors one more time, and then we can close it out. So Adabra sponsors Quarterly, our food, and that's Bradley. He owns this software consulting firm located in Murfreesboro, Tennessee, here just south of Nashville. For those that don't live here, our portfolio of custom contract work includes long-term repeat clients from New York to Chicago to Phoenix. Also Spinman, shout out to Spinman at Vaco. Headquarters in Nashville, Vaco provides expert consulting, permanent placement, and strategic staffing solutions for companies around the world. If you're needing a developer job, Spinman is the person to go see. Sweet. Thanks again, Bradley, for doing this talk, man. It was a solid talk.
Thank y'all for attending.
Awesome.
Thanks.
Sweet. Everyone have a good one. Looks like we got up to 8 people today, so that's awesome.
Sweet.
Nice.
Sweet. See y'all.
Y'all have a
Thank
good
you.
one.